Hello, May class, and welcome to your next maths lesson. So in the previous term, we had started looking at fractions and we had started looking at adding them. And I think we just started having a look at how to subtract them. So we are going to continue our work with fractions today. But before we do that, I would like you to number 1 to 10, please, and you are going to be completing your arithmetic. So I'm going to pause, well, you're going to pause the video now and complete the questions that have been put on here. And then once that is complete, when you unpause the video, the answers will be there and then we can go through the answers. So pause the video now and complete the 10 questions that are in front of you. Okay, as you can see, I have written the answers onto our page. So 8 times 7 is 56. What is half of 160? It is 80. What is 46 as a Roman numeral? It is XLVI. 4 9ths plus 2 9ths. The denominator is the same, so you add your numerators. So it's 4 plus 2 is 6, 6 over 9. 6 times 7 is 42. 16 divided by 8 is 2. What is an equivalent fraction to 5 over 12? Right, remember we spoke about equivalent fractions. What you do to the top, you do to the bottom. So I times both by 2, and I have 10 over 24. Yep. Then you could say, 4,562 plus 2,432. The answer is 6,994. 7,896 minus 2,342. The answer is 5,554. And 24 divided by 6 is 4. You could have checked that by going 6 times 4 is 24. You would count in sixes, so 6, 12, 18, 24. You could also count in fours, and there'd be 6 of them. So 4, 8, 12, 16, 20, 24. So all of that would have got you these answers. So we're going to move on now to our lesson for today. And our lesson is, can I subtract fractions with the same denominator? So can I use a number line to do this? Remember what we said about the denominator not changing, that just the numerator changes. So let's have a look. I want you to pause for a minute, have a look at this and think which one is different. So have a look, which one do you think is different? So pause the video now and see if you can find the one that is. I've worked out the answers for these and I can immediately see which one is the different one, and the answer would be 10 over 8 because these two equal 6 over 4. Oh, sorry, it's these, yeah, these two here, because this pair, because this is 9 over 6, this is 9 over 6, this is 6 over 4, that is 6 over 4. This one, 5 over 8 plus 5 over 8 gives us 10 over 8, and this one here, we've got our whole is 1, 2, 3, 4, 5, 6, 7, 8, and we've got 8 there, 9, 10, 11, 12. So these two are not equal, which means these two are the different ones. Moving on. Have a look at this question. It says, Harry takes 2 identical strips of paper and folds them into 8s. So this is one whole, obviously that is one whole, so our wholes are 8 over 8. Explain how he can use these pieces of paper to find the answer to this question. So it says 12 over 8 minus 5 over 8. Now I'm going to help us with that. We know that 8 over 8 is going to be if these were all colored in. So 1, 2, 3, 4, 5, 6, 7, 8. But we start with 12 over 8. So we've got these 8 and then we use another 4 from here. So 12 over 8 would be 8, 9, 10, 11, 12. So the colored in ones are actually showing us 12 over 8. And it is saying minus 5 over 8. So if I used a different color, let's use red, and it says to take 5/8 away from the 12/8. So I'm going to cross out 5. I'm going to go 1, 2, 3, 4, 5. Okay, I've crossed them out because it says minus, which means you're taking away. So I've taken away 5/8, and I'm left with 1, 2, 3, 4, 5, 6, 7 of those 8s. So actually 12/8 minus 5/8 is going to give me 7/8. So why do you think that's happened? Have a look at the question. Think about what we've discussed before about adding our fractions. If we add our fractions, if the bases are the same, we add the top number, which is our numerator. So if we were adding, we would add just the top number because the denominators were the same. And you can see that when we are subtracting, we're doing the same thing. The denominators are the same, so I'm taking away my numerator. So actually, that question could have just said to me, what's 12 minus 5? And I know that 12 minus 5 will give me 7. But obviously, it is still part of our 8s. That doesn't change. I'm not taking away any of my denominators. Those stay the same. The numbers that's changing is our numerator at the top. And it is getting smaller because we're taking away. So we've got 12/8 minus 5/8 will give me 7/8. So I want you to now get yourself 2 strips of paper. They can be identical. Fold them into 8s. And remember how I showed you how to do that? You can fold it in half to make 2, then you fold that in half, it makes 4, and then you fold that in half, it will make 8. So have 8 equal strips. On those strips, you would have 2 strips of paper that show you 8s, and each strip of paper would show you 8 8s. Use those strips of paper to help you answer the following questions. 6/8 minus 3/8, 9/8 minus 4/8, 14/8 minus 5/8. Your extension could be the following. Fold 2 strips into thirds, so 2 other strips, and then into half. Open them out. Write 4 subtractions that you could use these strips for to help you solve them. Sorry, let me just take this. So for example, if that was our 8, okay, we would say 6/8 minus 3/8. What does that give us? 9/8 minus 4/8, and 14/8 minus 5/8. So think about what I did in the previous video of how I did that. Use your strips of paper to show you these ones and find me answers for these ones. Here. And then write those in your book. Right, so use these bar models to subtract the fraction. So we've got 10/6 minus 5/6. You can see that this strip of paper here, this whole is going to show me 6/6, but it says that I need 10/6, which is why we've got 4 over here. So actually our question is obviously 10/6 minus 5/6. And using this, you can see that I'm taking away 1, 2, 3, 4, 5. And how many am I left with? So you can use the bar models to help you, or you can use what we've discussed about the numerators and the denominators to help you answer this question. Again, use the bar model or complete the bar model. So I would like you to draw this bar model and show me your working of how you subtract your fractions. Then underneath, I would like you to write your steps. So what are your steps to success when you are minusing your 9/8 minus 1/8 and what it leaves you with? And then can you give me an answer and then write it or convert it? So I'm going to give you a clue that your answer can be converted into something else. So it could be 1 whole, 2 wholes, There could be a mixed number. You tell me what it would be. Okay, so you would say 9/8 minus 1/8. Give me an answer, and then explain your steps of how you got it. Again, using your bar models, I would like you to answer the following questions. 9/3 minus 4/3, 11/4 minus 3/4, 25/16 minus 7/16. So again, using a ruler, draw your bar models. You may need to draw more than one. So for example, if it's showing thirds, they've actually drawn 3 bar models to go with that question. With the 16ths, they've actually drawn 2. And then with the quarters, they've actually drawn 3 bar models. They're identical, but help those, use those to help you work these out. Go back to your steps that you used as well and work through these. So I'm going to give you a minute to pause and draw these bar models, and then I will talk you through the answers. Okay, so 9/3 minus 4/3. So 9/3 is actually going to give me 9/3, which is the same as 3 wholes. So they've shown you 3 wholes here. There's 3, that's a whole, that's a whole, that's a whole, because it's 3/3, 3/3, and 3/3, which obviously all equal 1 whole. They each equal 1 whole. And we're taking away 4 of those. Okay, and we are left with an answer here of 1, 2, 3, 4, 5. So I've got 5/3. If you would like to extend yourself, can you convert that into a mixed number? Give that a think. Okay, so your mixed number would then be 1 and 2/3, because obviously 3/3 is equal to a whole, and then I'm left with 2, so I've got 1 2/3. With the next question, we were working with our quarters, and we needed 11/4. So we actually didn't need all of them, but we needed enough space to color in 11. So we've got 4 here, that's 4/4. This is 4/4. And this last one is actually going to show me 3/4. And I know if I add it up, I've got 4, 8, 9, 10, 11. So 11/4. 11/4 minus the 3/4 leaves me with 1, 2, 3, 4, 5, 6, 7, 8. It leaves me with 8/4, which again, can you convert this? I'm going to pause for a minute, see if you can convert this. And the answer is, I know that 4/4 is going to give me 1 whole. So 8/4 is actually going to give me 2. It's the same as 2 wholes. Our last question was 25/16. So this is 16/16. And then we would have added another 1, 2, 3, 4, 5, 6, 7, 8, 9, because that would have given us to 25/16. And they are taking away 7 of those. So, sorry, let me just write that down. So a 9/16, because I know that 16/16 plus 9/16 will give me 25/16. And you're taking away 7, which will leave me with an answer of 18/16. And this, again, I want you to try and convert your improper fraction to a mixed number. And our mixed number would then be 1 and 2/16. Okay? Because we know that 16/16 is equal to 1 whole. And then we're left with 2/16. So it's 1 whole and 2/16. Okay, so Sam says 11/9 minus 7/9 is equal to 4/0. What is the mistake that Sam has made? So pause the video and write me this question out and say, what is the mistake that he's made and what should our answer have been? If you have completed that, I'm going to then go through the answers with you. So 11 over 9 minus 7 over 9, he's got 4 over 0. What Sam has done is that he's minus the top number and he's minus the bottom number, which is the mistake he's made because the denominator is the same. So we don't minus it. We don't say 9 minus 9 gives me 0. 11 minus 7 will give me 4, but the answer should have actually been 4 over 9 because we do not minus 9 from 9. We are only minusing 11 and 7, okay, because the denominators are the same. With that in mind, these are your 3 challenges for today. Question A says 5 over 7 minus 3 over 7, and there is a bar chart to help you work that out, so please make sure to write that out and give me an answer. Then it says 7 over 9 minus 4 over 9, 7 over 10 minus 3 over 10, 6 over 6 minus 6 over 6, 8 over 93 minus 2 over 93, 8 over 3 minus 4 over 3. And you will notice that it's actually got 2 squares there. It says 8 over 3 minus 4 over 3 gives you something which is equal to something. Remember when we've been going through these that I've been converting our improper fraction to mixed numbers. So some of these answers will need you to do that. 9 over 5 minus 4 over 5 will give me an answer. And you will also notice that that again has an equal, then there's a square, and then there's another equal. So it's going to want you to convert your answer from an improper fraction to a mixed number. Question 2 has numbers missing. So it says 10 over 11 minus something over 11 will give me 7 over 11. So what is missing? Question B is the same. Well, question B actually says 10 over 11 minus something over 11 is the same as 7 over 11 minus 4 over 11. So remember what I said about the numbers on either side of our equal sign having to be equal. Question C says 15 over 4 minus something over 4 gives me 2. Now it's giving me 2 wholes, and that is your clue. They've already converted our improper fraction to a mixed number or a proper number. So think about what over 4 will give me 2 wholes. And then D is 11 over 4 minus 3 over 4 is the same as 11 over 3 minus something over 3. So give that a think, because this is going to give you an answer, and this answer has to be the same as this one. So how can we get that when the denominators are actually different? Then the last question says, Alex and Annie are taking turns playing a computer game. Annie plays for a total of 2 hours, 2.25 hours. Annie plays for 3/4 of an hour more than Alex. How much time do they spend in total playing the game? So Annie we've actually got a mixed number, and I'm going to help you a little bit with this one. She plays for 2.25 hours. So convert that to an improper fraction, okay? And then you are going to say that she plays this much more than Alex, okay? And then it says, how much time do they spend in total on the game? So think about how much they each spend and how much in total they would spend. It is quite a difficult one, so take some time to work that question out. Don't forget to share this with us on Tapestry, and please make sure your work is laid out neatly. If you are drawing, well, you should be drawing your bar charts today, your bar models, sorry, and that requires a ruler, so please make sure that is done correctly and that you've laid your work out neatly and that you've numbered it correctly.